Just comments immediately. Good evening, everyone. Thank you for taking time to join us for this learning opportunity. It's my pleasure to welcome everyone to the technical lecture on pipeline erosions control and soil stabilization using the HDPE geoscience system. So this topic is very critical, especially to pipeline integrity, environmental protection, and asset sustainability. And to do justice to this topic, we also have an expert engineer who is well versed on this topic, and I trust him to deliver to the best of his ability. So I will just run us through the outline for today. I'll be the one moderating this program. We'll start with the opening prayer, which is the third stanza of the national anthem. Then we're going to have a very short safety brief. Then we proceed to the opening remarks. We have the introduction of the guest speaker, which is going to be done by Ms. Sylvia. Then the technical presentation itself will be done by our esteemed engineer. Then we have the interactive question and answer sessions and the key takeaway to be done by Chika. Then we have the group photography as usual and the vote of thanks to be done by the program chair. Then we can conclude the meeting. So just like we have agreed, without wasting much of our time, we'll proceed straight to the third stanza of the national anthem, where we can recite the opening prayer. So I will just take this. We can as well join in reciting this. O God of all creation, grant
Grant this one request.
Help us to
Help us build a nation
where no
where
man
no man is oppressed,
and
so with peace and plenty, Nigeria may be blessed.
Amen.
Amen.
So next on the agenda is safety brief. We have Israel on call to take us through the safety briefing for this meeting. So Israel, you can unmute and take the safety brief.
All right, good evening once again, esteemed colleagues and professionals. Once again, welcome you to this technical lecture. And as is our practice in the industry, we like to take a moment to observe safety. Please, before I go on, confirm you can hear me.
Yes, you can be heard loud and clear.
All right, thank you. So just as usual, we are expected to mute our mic when we're not speaking. And if you have any reason to speak, please do well to raise up your hand by indicating with the raising of hand button. And if you have any comment or question, you can indicate in the chat box using either the C for comment or the Q button for questions. Also, if you are making use of your headsets, please make sure you can still hear the fire alarm at your end. And also be at alert and be aware of your environment at all times during the course of this session. And if you happen to be at a sitting position, please try as much as possible to maintain a sitting posture to avoid pains or whatever. And always remember that your safety is your first priority. So always stay safe and enjoy the rest of the program. Thank you.
Thank you very much, Israel, for that beautiful safety brief, telling us how to stay safe during this meeting and beyond. So the next will be the opening remark, and that will be taken by the section chair. That's Dr. Oluwaseun Adetono. So, sir, you may proceed with the opening remarks.
Hello, good afternoon. Good evening, everyone. It's nice having us all on this call. Distinguished members, professionals, and those invited on this call for this very lovely technical presentation. We know what SP is all about. It's all encompassed every aspect of our operation in oil and gas industry, whether it's civil, whether it's mechanical, every area that have impact on our activities are all part of what we are all about. So I want us to take our time, relax, and let us listen carefully with our pens with our recordings so that we can learn from the impact of what the presenter has for us. Is a good technical area, and I believe God helping us within the shortest period of time, we will learn from the professional dynamics that is involved. Actually somewhere being noisy in the office area, so you might tolerate me with my voice also cracked from several activities in Abuja in the last 1 week. So on this note, I would like to welcome us once again. Please let us encourage the presenter. I'm impressed with the number of participants I'm seeing. So please, let's keep this fire and listen tentatively, carefully with our devices, with our pens, so that we can learn from the presentation by the presenter. Thank you all. And I believe at the end of this, we are going to have a little rapporteur about this particular presentation. So let's, Mr. Presenter, thank you for honoring and making yourself available to present this topic to us. We are very grateful. We appreciate you. Please, moderator, you may proceed. Thank you.
Thank you very much for the inspiring opening remarks, section chair. I want to believe that everybody on call is eager to hear from our guest speaker for today, and which brings us to the next item of the agenda, which is the introduction of the guest speaker, which is to be done by Ms. Sylvia. So, Ms. Sylvia, you may proceed to introduce our esteemed engineer to take us through the lecture for today. Thank you.
Okay, good afternoon, everyone. Please let us make welcome Engineer Akinwale Akinsele, the Civil Engineer NDIC of NNPC Limited. Akinwale Akinsele is an energy professional with a strong interdisciplinary foundation in engineering and energy economics. He holds a bachelor's degree in civil and environmental engineering from Federal University of Technology, Akure, Futa, and a Master of Science in Petroleum and Energy Economics from Nasarawa State University, Turkey. He began his career as a civil structure engineer designer before transitioning into the energy sector. He currently works with Nigerian National Petroleum Company Limited, NNPC, as a natural gas plant operator, supporting the transportation of natural gas to NDIC's customers, primarily power generation plants across northern Nigeria. Akinwale is a firm advocate of safety as a way of life rather than merely a compliance requirement. This sociology earned him NDIC's Safety Star Award in 2025, reflecting his commitment to operational discipline, risk management, and workplace safety culture. In addition to plant operations, he oversees pipelines, right-of-way maintenance with a focus on erosion control, ROW utilization, and shore protection. He has successfully supervised and delivered multiple projects involving the deployment of HDPE, geocells, geotextiles, gabions, and Renon mattresses for infrastructure protection and rigidity. Akinwale is a registered engineer with the Council for the Regulation of Engineering in Nigeria and holds active membership with the Nigerian Society of Engineers, the Project Management Institute, the Nigeria State Institution of Safety Engineers, and the Society of Petroleum Engineers. Outside of work, he enjoys playing volleyball and is happily married with 2 children. So yes, this is our guest speaker for today, and we have seen from this, he is quite commendable. So please, Engineer Akinwale Akinsele, please, you have the mic to lecture us today. Thank you.
All right. Thank you very much, Ms. Sylvia, for the introduction of our guest speaker. So without wasting time, we'll just proceed straight to inviting Mr. Engineer Akinwale Akinsele to proceed with his lecture. Thank you.
Right, thank you very much.
Share the screen from your hand, or
Oh yeah, I will share from my end. I will share from here. The network is pretty good. Thank you so much, moderator. It's good to be here this evening, and I trust that we'll have a swell time together. So just a moment, I'm trying to share my screen. Okay, and I will unblock my camera so that my face can become visible. All right, good evening once again. Apologies, I'm dressed this way because I'm currently in a remote field location, and it gives me joy to share my experience on these subjects with professionals like myself. Kindly confirm once again that you can see my shared screen and that you can hear me and that I'm good to go.
We can see your screen. I can see your screen. I can hear you. You may just put the presentation, the slides on presentation notes. That was all. All right. Perfect.
All right.
Thank you.
Done that. All right. Thank you very much. I'll be presenting the topic, pipeline right-of-way, erosion control, and soil stabilization using high-density polyethylene geocells. Standing on existing protocols, you have been told that we need to be snappy, so I'll try as much as possible to do that. So this is my outline. I'll just take some 5 seconds for you to just glance through them. All right. So I'd like to lay some foundation based on the topic that we have before us, and I'd like to just take us through the basic definition of our key terms. Right, the topic speaks to HDP geocell. It speaks to soil stabilization. It speaks to right of way and erosion. Right, so I'll just dive in. So the HDP geocell, by the way, HDP stands for high density polyethylene. It's a 3-dimensional honeycomb structure that is made from high density polyethylene and used to confine soil and to improve strength and prevent erosion. Whereas soil stabilization, simply put, is a process of improving soil strength, basically the engineering properties of soil to make it durable. This can be achieved through mechanical method, chemical, or geosynthetic method, basically to enhance the load-bearing capacity to make the soil more compact and reduce possible erosion. So again, right-of-way, actually captured as ROW, apologies, is basically a designated path for pipelines installation. And obviously, we all have an idea what erosion is. Basically, it is the displacement by natural forces of soil. So this topic is important to me, and I'd like to, in the same vein, share with you why this topic matters. First of all, I'd like you to just take a look at the picture. By the left-hand side, you see an exposed pipe, right? That happens to be a right-of-way. And you can see the level of erosion that has occurred there. So this topic matters to us because in this part of the world, oil and gas pipelines are installed below ground. You know, unlike in Europe or other parts of the world where you see pipelines being installed at the surface. Here in Nigeria, majority of our pipelines are being installed below ground. And this topic is important to us because soil cover protects pipeline from exposures to vandals, heavy rainfalls, flooding, mechanical damage, etc. Also, it is important because erosion along the right-of-way threatens pipeline integrity, obviously, right? And it is important also because loss of soil support creates pipe sagging and joint stress, right? We know that our pipelines are being welded, the line pipes are being welded together to form a long piece of pipe, right? To flow whatever fluid that it is designed to flow, right? So we cannot afford to lose soil support because basically the soil serves as a support and also as a covering for these pipelines. This topic is important to us as well because exposures accelerate corrosion. Poor stabilization will increase rework and operational cost. The topic is important because this basically supports asset integrity and sustainability objectives. And last but not least, it forms a critical knowledge for professionals like you and myself. So can you just imagine seeing the picture being displayed? That practically is a sagging pipe from one end to another. Obviously, this pipe has been eroded. The soil cover has been washed away. Also, the soil support beneath has been washed as well. So if you are on a maintenance team for inspection and you encounter this situation, what are your thoughts? I mean, what really comes to your mind? This is just to paint a picture in our minds while we proceed. So for the sake of this topic, I would like to dwell on, briefly on each of these. I'll talk briefly on erosion and what are the types of pipeline right-of-way erosion that we usually encounter. So you need to understand that this I have narrowed the topic of erosion in this context to pipeline right-of-way, right? So right-of-ways are particularly vulnerable to different erosion types. The first type of erosion that our pipelines are exposed to is surface erosion. Basically, this is the gradual removal of topsoil, which can be caused by rainfall, runoff, or wind. Also, gravity as well. Also, we have gully erosion. Basically, this is the formation of deep channels, which is created by concentrated high-velocity water flow. And the third, which can be deadly, is the subsurface erosion. This is hidden because obviously we cannot see it at the surface. There are hidden soil losses occurring beneath the surface. It is weakening the ground support and often remain unnoticed until a major challenge occurs. So the common causes of erosion, before I go into that, I'd like us to look at these two pictures. The first one by the left, you see the picture depicts a soil structure, which shows the under parts, and you can see some parts where we see voids, right? And the second picture to the right shows a well-compacted soil. Right. Basically, there are two causative agents for pipeline right-of-way. And the first is human-induced. While humans do not have a direct impact on the soil to cause erosion, however, human activities such as deforestation, urbanization, and mining, right, can accelerate soil erosion. Also, we have natural agents like I talked about earlier, water, wind, and gravity. We know that intense rainfall and surface runoff will wash away soil cover, and that point is a point where the pipe is being exposed, and from there it can only get worse for the pipeline underneath. Construction-related soil disruptions, such as inadequate backfilling, which leaves the soil loose and unstable, can also cause erosion, right? We know that when during pipeline construction, when the pipes have been welded together, the next stage will practically be to excavate and then lower the pipes beneath, right? So after lowering the pipes, there's a need to cover the pipes back, right? So in the process of covering, we have actually disrupted the soil formation, right? And now while covering the pipeline with earth, we have created some more voids of air and maybe water, right? And that practically is the leeway for erosion to start, right? Another cause of erosion would be terrain instability. we know sloped areas, hilly areas, especially where weak soil structure is imminent. We know that erosion can occur due to gravity. Each of these elements can lead to rapid deterioration of pipeline support systems, increasing the risk of exposure and collapse. So I'll quickly dash to the concept of soil stabilization, right? The picture to my right shows an adversely affected right-of-way, right? There is a pipeline around there on that right-of-way, right? And this happens to be around my location, right? So what's the concept of soil stabilization? Soil stabilization is aimed at improving the engineering properties of the soil, right? So we know that in the soil structure, right, the presence of void helps microbes which lives within the soil. Voids would mean pores, right? And also those pores also create an avenue for oxygen, to reach plants and help them to grow, right? But where in excess or where the soil is naturally weak, it becomes easy for this soil to be displaced by hydraulic forces, in this case, water, right? Because those voids become so large in size that there is no longer friction between the soil particles, and it's easy for the soil to be washed off, right? So basically, reducing voids is essential to preventing erosion, as this will slow down water movement. It will enable soil particles to interlock better, making the ground less susceptible to score and displacement along the right-of-way. So basically, I'll just dash through these three soil stabilization methods. The first is compaction. The idea of compacting the soil is to first drive away excess voids in the soil, right? And in doing this, we are trying to increase the shear strength of the soil. Basically, shear strength talks about the soil's resistance to lateral movements or forces that wants to deform it by moving it away, right? So when we compact, the soil shear strength is improved and it makes it more resistant to movement. Compaction also enhances correction and friction, which prevents particles from being washed away. It improves density and compaction, right? Creating a firmer foundation around pipeline corridors. The second will be mechanical confinement. And I speak to this with respect to pipeline right-of-way, right? For example, geocell, which we will talk extensively on in the next slides. The geocells prevent lateral soil spreading and holds soil particles tightly together. And the third would be chemical additives. These basically bind loose soil grains and fill micro voids. So example of chemical additives would be fly ash, cement, and so on and so forth. Basically, this helps to bind this soil together. Looking at this picture, you'd see an exposed pipe, and you see that a part of the coating, of the pipe has actually been chopped off. This already has exposed this section of pipe, and you know that corrosion has already set in. So these are the kinds of menace that this topic is providing solutions to. So I'd like to take a little pause here for us to take in all what I've said. I've talked about soil erosion as it relates to pipeline right-of-way. I've talked about the concept of soil stabilization and why it is important and why we do it, right? So the next I'll talk about is the crux of today's meeting, which is the HDPE geocell technology. Right. The picture you're seeing at the right shows the geocell material. I'll just like to speak briefly on this picture. The geocell comes in panels. We call it panels, and it is foldable. And as soon as you want to spread it over, once this, the right of way area is prepared, then it is being expanded. And once you expand it, it forms cells, and that's where the name comes from, geocell. It forms cells, as you can see, and you can also see that each of these cells is perforated, right? And as these cells are, within this confinement of each of these cells is where the earth is being filled into, right? And the idea of the perforations is such that even if the earth field absorbs water, the water can easily, under very, very low velocity, right, find its way out of this formation without washing away the soil. And this is the game changer, right, for protection of right of way against erosion. Right. So basically, the geocell is manufactured from, HDP. We've talked about this severally. It is a 3D honeycomb confinement system. It transforms loose soil into a reinforced structure. Right. And also, it confines soil and distributes loads, lateral movement, and erosion velocity. So just like I said, the velocity, the runoff velocity is being reduced to the barest minimum. Why? Because the geocells has been able to help break down this speed. So why the choice of high density polyethylene? Why the choice? Why not? We also have low density polyethylene, right? So, but why the choice of high density? First is because of the density to strength ratio. That makes it is very light. It is light in weight, right? But it is very strong. And then this enables easy transportation and installation on site because of its lightweight. It has high chemical and UV resistance. Practically, this makes it very suitable for outdoor use, and also it has high resistance. This makes it have resistance against environmental hazards, such as environmental exposures. And then it is flexible yet tough. I've spoken about the density to strength ratio. It allows confinement of soil even under load. And then it has this long service life, reducing maintenance on pipeline right of way stabilization. So going forward, I'd like to speak quickly to engineering principles of the geocell stabilization, right? Basically, we've talked about increasing shear strength, and I just told you earlier on what shear strength is all about. And then the geocell material helps to stabilize the soil by improving the bearing capacity of weak subgrades. So this makes it find usage in access roads. Creation of access roads where the subgrade is very, very weak, right? It enhances friction and interlock of infield material. It reduces surface runoff. So the pictures to the right shows you a laid geocell panels on the right of way where we have some serious erosion. Not to worry, I'll take us through a case study in the next slides. So what are the applications in pipeline projects? Before I speak to that, I'd just like us to look at this picture. This picture has been able to shows us the different layers of installation, of the geocell material. You see, the first, the white part shows geotextile material. Basically, the geotextile material is, we shall be seeing that in the next slide. I'll talk extensively on that. And then you see the geocell material being laid and anchored to the ground. Then next, you see the geocell material is being filled with laterite earth, right? And it's being held in place by the cells. And then next layer, you see this depicts humus soil, being laid on top of the laterite material. And then the last layer would be your vegetation. Basically, we understand that planting grasses also help reduce the velocity of runoff. So all these properties makes the geocell suitable and makes it find use in embankment projects and erosion-prone areas, slope right-of-way sections, river approach and floodplain zones, valve station platforms, and access road over soft soils. So below is the installation process. I would not like to dwell so much on this. The previous slide I had already spoken about the different layers. Basically, that talks about the installation process. But key to this installation process is the anchoring of these geocell panels. So I can say that the beauty of the geocell material in preventing pipeline right-of-way erosion lies in the anchorage, because the anchor makes it stable to the earth. And if that anchor is not properly done, the erosion will eventually wash away all the soil and the geocell material inclusive. So that is why we need to take this very seriously. The strength of the geocell material to prevent erosion lies in the anchorage to the ground, and also the connection of the panels together. I mentioned earlier that it comes in different panels, and the panels are being tied one to another. So I just like to dash through this project case study. Apologies. Can you still hear me? Can everyone still hear me? I've been talking
Yes.
for quite a All right, thank you. I just wanted to be sure that I've not lost anyone. So thank you so much. So this is a project case study that I supervised. I was privileged to supervise. This is the project site. It's a riverbank area, and you can see this arrow showing an already exposed pipeline. The reason why it is exposed is not far-fetched. You see the environment, you see that it's at the riverbank, and the velocity of water hitting the right-of-way obviously would wash that off. So the problem is that the pipeline is exposed. It's a pressurized gas pipeline because basically involves human activities and then natural agents. And then the possible risks that this area stands is that there's a compromise on the pipeline integrity, because obviously the soil cover has been exposed and we cannot ascertain the integrity of that pipeline. And then exposure to possible gas leaks and explosion due to corrosion, and then fatality. What were the remediation plans that we put in place? The first was we had to reclaim the shoreline using gabion baskets. I'll show you what okay, so this is gabion basket. This is what it looks like. It's basically interwoven. It's basically interwoven basket of galvanized steel, which basically is filled with hardcore, huge stones to reclaim a portion of land and also to form a protection for shore areas, right? And also part of our plans included soil stabilization. We had to stabilize the soil, making it even more compact so as to be able to withstand, to bear the laying of the geocell and all that is coming on top of it. And also we installed geocell material on it to cover, and then we planted Bahamas grass. So the next few slides, I'll be showing us pictorial progress of the work from start to end. So basically, I talked about the shoreline reclamation. You see, the water body has already eaten up the right-of-way area, you see, and then we had to reclaim it back using hardcore filled gabion baskets, as you can see in the second frame. And then third frame shows earth filling and stabilization process. And then the fourth frame shows the installed geocell material. And then after the geocell was laid, the next thing was to start filling the cells with lateritic soil. And you see, even the sixth frame shows that filling of the installed geocell with lateritic soil. And then this is a completed filling. And then the eighth frame shows us the completion of compaction. So after the laterite was being filled, after the geocell was being filled with laterite, the next thing we did was to now stabilize, that new filling. Basically, I told us, if you remember, when we do compaction, the essence is to ensure that the voids within the soil is being expelled as much as possible to make the soil more compact. So that is what was done here in frame 8. Thereafter, we laid humus soil on the right of way. Basically, this is because we're going to plant vegetation on it, Bahamas grass, and this is the planting. And then this is the finished project. So this basically returns the eroded site back to its natural ambience, right? And this practically, okay, the next slide shows the before and after pictures of the project. So the project the site went from this to this. Right. So what are the project benefits of using the geocells? Basically, it helps improve slope stability, reduce erosion and soil displacement. It lowers life cycle maintenance costs. Very important. And also it can be installed faster, unlike using concrete solutions, right? Especially in these kinds of location where transporting, the elements you need to make concrete to these remote locations might be very, very tedious and Herculean. So this is much more faster and it solves the problem. And another benefit is that it enhances HSE and environmental compliance. From the picture you saw, you see that the site was returned back to its original state, and then with the planting of grass on it. So I like to compare the idea of using HDPE geocell with other stabilization method. I've spoken to us about geocell, that it is best practically for right-of-way protection and shorelines. And based on experience, the cost is moderate. The flexibility is the topping, on the cake, right? It's highly flexible. You can work with it, and because of that, it has a very fast installation speed, right? For riprap basically means placing huge stones to break water velocity. The cost can be high, and the flexibility is low, right? And installation speed is moderate. Gabion basket is best for riverbank stabilization. You see in that case study that I shared with us, we use Gabion basket for river stabilization. The cost ranges from moderate to high, and it's moderately flexible, and the installation speed is moderately fast as well. Then the last is concrete lining. Basically, this is best for permanent hydraulic channels, basically for your drainage and all that. And then the cost is very high, and then it is very, very low in flexibility. And then installation speed is slow as well. So I like to say something very important, that engineering judgments, in deciding which of these methods, which of these stabilization methods against right-of-way erosion to go for, selecting any one of these will depend strongly on engineering judgments, right? It depends strongly because in some cases, concrete lining might just be the perfect solution, right? And in some other cases, geocell would work perfectly, right? But engineering judgment, this is where engineering judgment comes handy. And then you see that no single solution fits all terrain. So you must know when to use which. However, deploying the use of HDPE geocell, as we see, is very flexible and is very fast, especially for surface erosion. So the limitations for using HDPE geocell, basically it requires proper anchorage. I told us earlier that the strength of the HDPE geocell basically lies on the anchorage to the ground. So the anchorage needs to be properly done. The installation quality determines the performance, obviously, right? And it's not to be a replacement for structural retaining walls. And then, like I said earlier, engineering judgment is critical in the selection. So this practically speaks to sustainability in terms of the choice to use geocell material for erosion control. Basically, as against concrete, right? It provides a lower carbon footprint as against concrete. Basically, this speaks to the amount of energy that is required to manufacture cement, which is one of the chief components of concrete, right? Transportation also of this basically speaks to energy consumption, right? So going for HDPE geocell, it lowers carbon footprint and it is 100% recyclable, right? And it also supports vegetation growth and natural aesthetics. It reduces material haulage requirements. It improves climate resilience, and also it is relevant. The choice of HDPE geocell is relevant for ESG-focused projects. So I've actually come to, I've come gradually to the end of this, my slides, and I'd just like to take these key points to note. First, that erosion control equals pipeline integrity, right? If we're able to control soil erosion, whether surface, whether gully, whether subsurface, what we are doing in essence is that we are ensuring the integrity of our pipelines, right? Geocells enhance soil performance via confinement. Yeah, we saw that. We need to assess soil type and hydraulic conditions carefully, right? And the fourth point is that installation quality is very critical. This can never be overemphasized, right? And the fifth point is that we need to think life cycle cost and not just CapEx. So I think I'd like to stop here because of time. There was supposed to be a discussion, and I think there's also a quiz. Right, but for sake of time, I'll just end here, and I'm happy to receive questions. Thank you for listening. Over to you, my distinguished moderator. Thank you.
Thank you very much, distinguished engineer. This is very loaded. It was timely and as well impactful. In fact, I can say I've learned enough to supervise any erosion control work that might be applying HDPE anytime soon. I've learned quite a lot in this very short time. Not to waste time, I will just go to the next item of the agenda. Just excuse me for a minute to go back to the outline. And that is interactive question and answer. So I'll just invite Chika to coordinate the question and answer session and also the key with. So Chika, you may proceed.
While she's doing that, please
Good
we just
evening,
have 10
everybody.
minutes. Let's see how we can play around it. Thank you.
Good evening, everyone.
Yeah, good evening, Chika. You may proceed.
Okay, it's time for question and answers. Please raise your hand if you have a question, and if you want to make it speaker for us, you can drop it in the chat box. You
can see that we'll have just 10 minutes for the question and answer. So we might be entertaining just 2 or 3 questions at the maximum.
Confidence, we have some hands that are up already.
Okay.
Yes.
Lucky, unmute yourself and ask your question. Please be brief so that we can be able to accommodate more if possible.
Okay, thank you very much. Thank you, Akinwale. So my question is from the last slide you present. I think the last 3 slides you presented, where you showed the comparison between the various solutions. If you could please just go back. Yeah, this. So the comparison here, you mentioned 4. And according to your presentation, you mentioned that each of these methods is determined by engineering advice and solutions. So for geocells, which this presentation was about, are there other methods that you can put side by side with geocells for slopey right-of-way protection that is just in the class of geocell that when you compare the both, you can say, okay, let's go with geocell. That's the first question. Then for the second question is,
Hello.
Lucky, are you still with us?
Yeah, it seems I lost
It
his
seems-
audio.
So you can answer the first question that he
Yeah, so
asked.
thank you so much. Thank you, Lucky, for the question. So basically, right, the choice of I mean,
yes,
engineering judgment.
apologies.
Can you hear me?
Can you hear me? Yeah.
Yes, I can hear you.
Okay, yeah. So the second question, apologies, I think I lost
Okay.
you. The second question would be, you mentioned LDP, right? As opposed to the high diethylene, solution, which is geocell. You mentioned the low quality of it, right? So
Yeah.
I didn't hear application for the low quality is also, I think it's something that I'll need you to shed light on.
Okay. So can I just go ahead and answer?
Yes, please go ahead and
Okay.
answer.
All right. Thank you. So practically, the choice of HDP and why not DPE is practically simple, right? Both of them are byproducts of, they're product of crude oil, right? LDPE finds usage in plastics and another manufacturing, but for right-of-way protection and for the manufacturing of geocell material, the HDPE material is what is being used. I have never come across geocell material that's been manufactured with low density polyethylene. I was just trying to open our minds to the fact that there is something like low density polyethylene, but for right-of-way stabilization and for geocell manufacturing, it is HDPE that is being used. I've not come across manufacturing that is being done with the other one. Then to your first question, so practically, right, you can decide, without engineering judgment, without proper decision making, you can decide to use any of these for right-of-way, erosion control, but you end up spending practically maybe more if you choose the wrong method to solve the issue of soil erosion on the pipeline right-of-way. You practically probably spend more, waste time, right? And then probably be contributing more to our carbon footprint and all of that, right? But for other methods that works, just as Joseph works, just like I said earlier, you can decide to use any of these. You can decide to go for riprap. Like I said, riprap basically is the idea is to place big stones, on this right of way to help break down the velocity of this running water. You can decide to install gabion basket as well. It will do the same thing, but is it economical? Are we optimizing our funds, right? So practically, that is why the caveat is there that we need to use engineering judgment to pick the best, right? Thank you. I hope
Thank you, sir.
I was able to answer that question. Thank you.
Yes, you answered it very well. Okay,
Thank you.
we have 2 more hands raised. That's Akalugo Israel and Ogene Nelson. So it's only these 2 persons that we are going to take their questions due to time. The last person, sorry, we cannot take your question because of time. So
They
Nelson
can drop the
and
question. Apologies, they can drop the
drop
question in the chat box.
chat
Yeah, I'll
box.
reply. Yeah, thank you.
So Nelson and Israel,
Yeah.
please.
All right. Thank you very much, Confidence. Thank you to the speaker. Wonderful lecture indeed. Okay, just a quick one. I think while representing, you talked about sustainability, and from the pictures you showed, I was just thinking, right? This is a plastic, right, and it's subject to deformation over time, and I would just want to ask, because you also mentioned something about can be reused. So I think you're talking about maybe recycling and the rest. And I believe this will have some kind of environmental limitations, and also recycling might also be cost implicating, right? So given these long-term maybe deformation and also the recycling or environmental limitations for this, like what measures from the projects, what measures did you consider, design measures, I would say, as an engineer, to minimize like this long-term risk, so that you will not see your work being deformed maybe over time again, especially when maybe subjected to like high load or something. Yeah, thank you.
All right. Thank you so much for that question. So practically, the right of way is a designated part that is meant for pipeline installations, right? It is not meant for any other thing apart from that. So it is not expected that any other loads, come on it. And then talking about the sustainability aspect of installing geocells, so practically that is in the context that in comparison with volume, or in terms of the volume of geocell you will require to cover a certain expanse, right? It reduces the carbon footprint such that if you compare with concrete, you get to use a whole lot of volume of concrete, and all that. So, but for the geocell material, it's practically just that, and it is highly recyclable as well. So you don't, for concrete, once, for instance, once it is been probably has issues and maybe it's broken, you need to fix again, you cannot recycle. But unlike that, the idea of the geocell helps keep the production in check, and since it can be recycled as well. I don't know if I was able to answer that question.
You did, sir. Thank you very much. So
apologies, guys, if I can chip in terms of the sustainability. Engineer Nelson, you will see that after the application of the geocells and the laterite filling, there is a compost soil that is applied that supports vegetation. So, which is very, very key in environmental rehabilitation, and it restores the original ecosystem of that environment. And it allows, pipeline, there might be need for segment repairs. And if you use permanent solutions like the concrete, it will be very difficult for you to expose those segments that you want to work on and whatever. So that's why you use those materials that they are flexible. You can easily remove and reinstall. So thank you very much. I hope that helps. Thank you, Akin.
Thank you so much,
Okay.
distinguished.
Israel, can you be brief with your question so that we can take it? Please be brief as possible.
Okay, I already dropped my question in the chat box, but I will
Okay,
just
that's
ask
perfect.
anyways.
Don't worry.
Mm.
Let me read it so that
Okay.
he said, what are the economic implications of implementing the geocell technology? If, for instance, we are running a pipeline for 1,000 kilometers in a susceptible area, and we are also essentially running the geocells materials along the entire span. So what will be the economic implications of implementing the geocell technology?
Thank you so much. So the idea is that the geocell, if you see, I shared a table the other time, this particular one. So mind you, we use geocell solution where we have issues of erosion, right? So if you are installing a pipeline, if it's a greenfield installation, provided all the necessary soil stabilization has been done, compaction of the subbase and all that, and pipeline is being installed and all and covered properly, and there are no excess voids, you can be rest assured that you might not actually need to have, you might not have issues of erosion, washing away of your soil. But we deployed this method where we start having issues of erosion and all that. And practically from this table you see, and from experience, it is cheaper compared to other solutions, because practically you are just installing geocell. It is very fast, and then you are again returning the environment back to its original state by planting vegetation on it. So it is one of the cheapest solutions so far. Thank you.
All right. And sir, please, in just like 30 seconds, can we answer this last question? What's the cost implication, particularly if to be deployed on a right of way running 100 kilometers and above distance?
He has answered the question. It's the same thing. Yeah. Thank you. He has answered it. Yeah.
All right, that's good. So we have come to the end of our question and answer section. I hope even those that did not ask questions, the questions of others have accompanied the ones that you may want to ask. So it's time for key takeaways. The topic is very, very interesting. Like, it's something that we all need, fellow professionals, just like he said. He talked to us about the overview of erosion, how it happens, the implications and everything. Then he now brought to us the game changer of this technology. And we can see that it is very, very interesting, even in your company, or if something like this is something you can bring to your company to be a game changer. Maybe if others have not even heard of it, it can be something you can bring to their knowledge. And okay, finally, what I also want to add is, just like when Lucky asked the question, why the engineering judgment is very, 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 very important is because with the engineering judgment, you will make an informed decision so that all the implications, you will bypass it, you will avoid it. But when you do something blindly, that's what it means. When you are not informed, you end up losing what you don't expect to lose. And loss in our industry is something that should not be entertained. So I think we have done justice to this section. Over to you, moderator.
Okay, thank you, Confident. So the next agenda is going to be photographs. So we can all share our videos Let me check who is going to handle that. So that will be handled by Anthony.
Mr. Moderator, I think you will help us do that because I can't see Anthony on the call.
Okay, to be honest, so that we don't waste our time, I may struggle a little bit with this. So, is there any other person that can do this?
Okay, let me handle it.
Okay,
so
right,
let's on our videos, please, and smile. Don't forget. Yes.
Ah, Mr. Bashir, I like your glasses though. Are you sure you know where to it to me?
No. If I give you, what would I use in seeing?
You buy another one.
Okay. All right. A lot of cameras are blocked, so I'll go again.
You did not say SPE, so that we'll do thumbs up.
Okay, SPE, Solutions People Energy.
Solutions People Energy, SPE.
All right, thank you very much. Over to you, moderator.
Okay, thank you very much, Bashir. Just the last item on the agenda, which is going to be the vote of thanks, and that will be given by the program chair. Sir, you may proceed with the vote of thanks.
Okay, thank you so much. What an interesting session. Really appreciate on behalf of the section chair, the board, directors, everyone present. I want to really appreciate Engineer Akinwale. Thank you for this very practicable, real presentation that we all can relate with. Very interesting. The sustainability part embedded in this whole process of improving slope stability, reducing erosion, lowering lifetime maintenance costs, faster installation, and all those enhancements of HSE for this high density polyethylene geocell method of right way control is quite impressive. Thank you very much. I will really appreciate you. And we pray that you continue to excel in your careers and other field of endeavor. Today's technical lecture, again, I want to thank everyone. The number here is very motivating and encouraging. Close to 50 numbers, particularly when compared in recent time. Please, I want to clap for everyone. Thank you so much for your time, and a lot of people have really waited patiently. Thank you. Please, let's continue to improve this way, and I think we'll continue to encourage one another. So I think it's a great way, it's a great day, so that for other people, colleagues who are fasting, we'll have to quickly close for now, and see you next month. Thank you, and have a great day. Bye.
Thank
Bye.
you.
Thank you. Bye-bye.
Confidence. Bye-bye.
Bye.